All right, I couldn't find my other video about polyatomic ions and a little bit of helpful tips to remember them, so I'm remaking it. As we have on your list of polyatomics, we have these 8 ions as the first ones that you're supposed to learn. They're in bold, so that is something that you should memorize. There is a mnemonic. If you search it online, you can find something about Nick the Camel, polyatomic ions. It's just a way to remember what sulfate and nitrate and carbonate, phosphate and chlorate are. So however you memorize them, you have to know what they are. I'll draw them underneath here. So sulfate is SO4 with a -2. Nitrate is NO3 with a -1. Carbonate is CO3 with a -2. Phosphate is PO4 with a -3. And chlorate is ClO3 with a -1. So again, there's a mnemonic to try to help you remember that. There's not really a super easy pattern for how to learn it, but sometimes the acids can help. For example, if you remember that sulfuric acid is H2SO4, then you can know that hydrogens are usually positive. So if there's 2 of them, the sulfate can be a -2. But the rest of this, these tips assume that you know how to do these 5 ions. So once you know how to do these 5 ions, the ite ions have the same charge, but they have 1 fewer oxygen. So to get from sulfate to sulfite, you just change the number of oxygen, but not the charge. So it would be SO3 with a -2 charge. Nitrite, the same way, we would take away one of the oxygens, making this NO2, and we would keep the charge the same. There is not really a carbonate ion. Let's draw a little X there. Phosphite, we would take away 1 oxygen, PO3, and keep the same charge. And chlorite, we would take away 1 oxygen, getting a ClO2, and we would keep the -1 charge. So for chlorate and chlorite, you can actually go a little bit further. We have something called perchlorate. So this prefix per is a sort of short prefix for hyper. If something's hyper, it's too high. If you have hypertension, your blood pressure is too high. So hyper means something is too high, it's higher up. That's why I drew this up above. So the number of oxygens is higher. You would have this be ClO4. Again, you would keep the charge the same, -1. And then hypo means something is too low. Like if you're hypoglycemic, your sugar level is too low. So this has a lower amount of oxygens, just 1 oxygen, so ClO with a -1 charge for hypochlorite. Another thing that we can do is add a hydrogen ion to something, and that makes it a bi whatever it is. So we have bisulfate and bicarbonate and bisulfite. Instead of bi, you could have hydrogen as the prefix instead of the prefix bi. So biphosphate is not as common. A lot of times we call this same ion hydrogen phosphate. You can call it hydrogen sulfate or hydrogen carbonate as well, but for those, bisulfate and bicarbonate are more common. So what do we mean by a hydrogen? We're adding a hydrogen ion, which is H with a positive charge, a +1 charge. So if we add hydrogen with a +1 charge to sulfate, we get HSO4, because we've added the H, and we also have to add the charge, the +1 charge, to a -2 would make a -1. So -2, if you add 1 to that, you have just a -1. The same thing with carbonate. If you added a plus to that, first we're going to add the H, HCO3, And then when we add the plus charge, then the -2 changes into a -1. For phosphate, if we add a hydrogen, we have a hydrogen here, HPO4, and the -3 changes into a -2. For phosphate, we can actually go further and add a second hydrogen, making dihydrogen phosphate. So now we have 2 H's here. And then the -2, basically we've taken a hydrogen phosphate and added another one on here to make dihydrogen phosphate. So the charge is now only -1. We've added 2 pluses to the -3, or if you want to think about it as 1 plus added to the -2, either way you get a -1 for the dihydrogen phosphate ion. Oh wait, one more over here, the bisulfite. Sulfite can also have an H plus added to it. That would make it HSO3, and the charge would go down to a -1. So the nitrate really doesn't have this happen, because if we added an H plus to the nitrate, we would have HNO3, and the charge would go down to 0, which makes it not an ion anymore. So that's not one of our polyatomic ions that we have to learn, because HNO3 is not an ion, it's just nitric acid. So we don't actually have the binitrate or binitrite ions. Let's get that off of there. So we don't have it for nitrate or for nitrite. Okay, so starting with those 5 ions, if you learn them, you can use these tricks to get a number of more of them. Let me see, so you're getting from 5 up to 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can get from 5 ions to 16 ions, and that's most of the chart. So hopefully this has been helpful.